Welcome to pre-lecture video number 10 as we head into probability. Let's begin with throwing around some lingo that's commonly used. The chance of something occurring, the chance of an occurrence. And what is chance? What does that mean? So when we say that there is a chance of something occurring, we would say the chance of something occurring is equal to the number of ways that it can happen. So the number of occurrences, the number of ways that it can occur, divided by the total number of possibilities. So let's use an example here. Let's think about cards. In a deck of cards, we have 52 cards. And we've got 4 kings, 4 queens, 4 jacks, 4 of each type. 4 twos, 4 threes, 4 fours, all the way through. So let's think about the probability of selecting, just throwing our hand into a deck of cards, nice and randomly, it's all shuffled up, and randomly pulling out a king. So what is the chance that we randomly select a king? So we're going to look for the probability that we pull a king. So this is just shorthand, the probability that we pull a king out of a deck of cards. Well, let's first think about this denominator here, the total number of possibilities. In a deck of cards, how many different cards could I have picked out? Well, we said there were 52 cards, so that means there were 52 possibilities total that I could have selected. And the number of occurrences, well, how many different ways could I have picked a king? How many different kings are available for me to pick? And in a deck of cards, we said that there's 4 of each type, 4 of each number or face card. So we would say that there are 4 kings out of 52. So there are 4 kings out of 52 total cards. So we say that the chance of randomly selecting a king is 4 out of 52. So then let's just solidify that just a little bit further and talk about another statistic favorite, dice. On dice, we have 6 sides to die. We've got one side that says 1, one side that says 2. We got a 3 side, a 4 side, 5 side, and a 6 side. So let's say that I roll this die, it's not weighted, it's a fair die, and I want to know the probability of rolling a 2. So the probability of rolling a 2. Well, first let's start with that denominator again. How many total possibilities could I have rolled? Well, I could have rolled any one of these 6, right? There are 6 options to a die. So I could say that there are 6 different options for me to have total. So 6 possibilities. 6 possible sides to a die. And what am I looking for? I'm looking for the side that is a 2. So does that mean I want to put 2 out of 6? No. We're just talking about 2, meaning this side of the die, what that looks like. It has nothing to do with the number that's on the die, right? So we would say that there are 6 total possibilities, but only one of these 6 says what we're looking for. So we have 1 out of the 6 options that fits what we're looking for. So we have 1, 2 out of 6 total sides. So the probability of rolling a fair die and rolling a 2 is going to be 1 out of 6. And let's just go into one a little bit different from that, just to really solidify here and send the point home. Let's say that I have a classroom full of students, and I have some boys. I have 4 boys in my classroom, and I have 3 girls. It's color-coded, very gender biased. But, so, here are my 7 pupils. I have 7 total students in my class, and I want to know what's the probability that I randomly spin around in the classroom and randomly pick out a girl. So what's the probability that I pull out a girl at random? Well, we want to go over the total number of possibilities. So how many possible students could I have selected? Well, there were 7 possible options, right? 7 total students. I could have selected any one of them. What's the probability that I select a girl, though? Well, we got we got one girl, two girls, three girls. So that means there are three different ways that I could have selected a girl. So the probability of randomly selecting a girl from my classroom is 3 out of 7. So now when we're talking about chance, it's important to mention that chance runs from 0 to 1. That might sound a little bit strange, but we can think about that as 0% chance to 100% chance. So we could either denote chance in terms of decimals or fractions, or in terms of percents. And so when we think about it, the chance of something occurring is, the chance that something occurs and the chance that something does not occur has to equal 1, right? That's why this can only go to 1. You can't be 110% sure of anything, right? You can only reach that max of 100%. So the chance that something occurs, and the chance that something does not occur, let's see, something that does not occur has to equal 100%. That there's no other option. There's no halfway point. There's no way for something to kind of occur, or something to kind of not occur. These are definitive categories, and something can either happen or it doesn't happen. And those are the only options. So the probability that something occurs and the probability that something does not occur has to equal 100%. So one common thing that we read all the time in the newspaper and we see on TV all the time is the weatherman trying to predict the probability of rain, the chance of rain today, whether or not to bring an umbrella. And when the weatherman says that there is a 40% chance of rain, even though he hasn't explicitly told us, we can infer that that means that there is a 60% that it's not going to rain, right? Because it can either rain or it can not rain. Those are the only two options. So that means that that equals 100% of our total possibilities in terms of rain. So the chance that something happens or that it doesn't happen equals 100%. And that's particularly useful, and we'll see that even just a little bit later in this pre-lecture video. Now, what about the probability of two events occurring simultaneously? This is going to be the meat of the lecture. This is really what we're going to try and get across. The probability that two different occurrences happen together. Now we're going to look at the probability of two events happening, both events occurring. And in this case, we are going to discuss the multiplication rule. When two events occur, but the first event does not change the probability of the second event. So we're going to say that these are the probabilities are independent of each other. So that's what I'm going to focus on here. So the multiplication rule of independent probabilities. So, and in lecture, we're going to go a little bit in depth, because this is not always the case. What do I mean when I say that these two events are independent? Say I am going to flip a coin. When you flip a coin, you always have two options. You can either get heads, or you can get tails. You've got a 50% chance of each, right? There's two sides, and you have one head out of the two sides, and you have one tail out of the two sides. Say I flip my coin, and I get a head. Does that make my second flip of the coin any more likely to be a head because the first one was a head? Or any less likely to be a head because the first one was a head? No, the two events are totally independent of each other. A coin doesn't have any memory. So the probability of the first coin flip is totally independent of the second coin flip, and the third coin flip, and the fourth coin flip. The probabilities don't change with each flip, right? So these are independent of each other. Later in lecture, we'll go into dependence, where the probability starts to change once you begin to play a game in Vegas, let's say. So we're going to think about this. Now, so what's the probability, what's the likelihood of having two events both occur? To hit the jackpot twice, right? So let's think about flipping a coin twice. We know that flipping a coin once, we have a 1/2 chance of getting a head. Well, what if we flip a coin twice? If we were going to flip a coin twice, let's say I'm concerned with the probability of flipping a coin twice and getting two heads. I want to get back-to-back heads, right? So what's the probability here? So this is going to be called the multiplication rule, where we take the probability of the first head occurring and we multiply it by the probability of that second head occurring. So in this case, we have a coin and we have a 1/2 chance of rolling a head on the first flip, and we have a 1/2 chance of getting a head on the second flip, because there's always one head out of two sides. So we're going to multiply those together and see that we have a 1 in 4 probability of rolling 2 heads. But how can I prove this to you? How can I make you really believe it? I could throw numbers at you all day and you wouldn't believe it. Well, let's think about what can happen when we roll a die. We can get a head and a head. We could get a head on the first one and a tail on the second. We could get a tail on the first and a head on the second. Or we could get 2 tails. Are there any other possibilities that you can think of? That covers all the bases. So as you can see, we have 4 total possibilities. So we have 4 possible options, and only one of them fits what I'm looking for. So we have one combination out of 4 total combinations gives us that 1/4, that same thing that I did there. So instead of having to draw out every single combination that's possible when we get into more complicated examples, we can just go straight to the math and figure out the probability of the first event occurring and multiply it by the probability of the second event occurring. And now, remember when we said that 2 events occur, or when an event occurs, it either happens or it doesn't happen? Let's go into some more complicated examples where maybe it might be easier to find the probability of it not happening.